Okay, so I think we got the idea of what a term is. Okay, so now an algebraic expression, ladies and gentlemen, is the sum or difference of the mathematical terms that we just talked about in number one. So, please type for me an algebraic expression. What would an algebraic expression be? An example if we are trying to find the sum or the difference. Enter. Uh-oh. Do y'all know what sum means? What's sum mean? Come on now. None of you know what the word sum. Yes, sum means to add. What does difference mean? There you go. Difference means to subtract. Very nice. Yeah, there you go. Oh no, Les, don't put it in the form of an equation. It's an expression. Ella, there you go. 3x plus 5. Whew. 3x plus 5. 3x is a term. 5 is a term. So when we add them together, we have an algebraic expression. 5x squared y plus 2xy squared. There's an algebraic expression. 7x squared minus 3y squared plus 4z squared. Ladies and gentlemen, that is an algebraic expression. It's just terms, algebraic terms that are added or subtracted. All right. Going on. The number of terms in an algebraic expression will determine the type of polynomial that it is. So if there's only one term, it's called a monomial. One term. 3x. If there's one term, ladies and gentlemen, it is a monomial. If there are two terms, 2x minus 6y, it is called a binomial. And if there are three terms, like this one up here, it is called a trinomial. Shall we continue? Great. So, ladies and gentlemen, a coefficient, once again, we're talking about terminology. A coefficient is the numerical value of a mathematical term. Uh-oh. Okay, so give me a mathematical term. Type one in real quick. Give me a mathematical term. Anybody? A mathematical term. Thank you. 7y. There is a mathematical term. 9x, mathematical term. Thank you very much. What is the numerical value in this term? What is the numerical value in 7y?
7.
Thank you. It is 7. What is the numerical value in 9x? 9. Great. Those are your coefficients. Now, bonus knowledge that you guys, this is so important that you understand. What does a coefficient tell you? What is the significance of the coefficient? What does it tell you?
It's being multiplied by something.
Wonderful, and that's what I expected you to say. Ladies and gentlemen, when you have 7y, it means 7 times y. But specifically, what does the coefficient tell you? Great, I'll tell you. It tells you how many of something you have. Okay? If we have 7 trucks, we say 7 trucks. 7 tells you how many of something you have. So if I have 7y, this tells me that I have 7 y's added together. That's the significance of a coefficient. It tells you how many of something you have. You want to write that in your notes and remember that. Okay? A coefficient tells you how many of something that you have. Now, why do we need to know that? Well, because when it comes to like terms, you guys have heard the word like terms, yes? Like terms? What are like terms? Well, like terms are terms that contain the exact same variables and exponents of the variables. So in a mathematical term, the variables and their exponents must be exactly the same for the terms to be like terms. For instance, 3x and 5x. Ooh, I don't want to write plus. 3x and 5x. These are like terms because they both contain an x. 7x squared y cubed and 3x squared y cubed. These are like terms because the variables and their exponents are exactly alike. Now, if the variables and their exponents are exactly alike, ladies and gentlemen, that means that we can add and subtract them. Only if they're like terms. So let's try 3x plus 5x. And you guys know this. What is 3x plus 5x? Type it in, ready, go. Yeah. 8x. Whew. Y. Why is 3x plus 5x 8x? You add them. Yes, you're correct, but what are you adding? You combine like terms. That's what you guys have been told. But combining them isn't adding or subtracting them. It can be any of them. Ladies and gentlemen, this is what I want you to understand, okay? If you understand the idea that a coefficient tells you how many of something you have, if I have 3 x's and I add 5 more x's, then I have 8 x's. Please understand that the variable part, the thing that makes them like terms, does not change. The only thing that changes is the coefficients. So in actuality, you're not adding the terms together, you're just adding the coefficients. 7x squared y cubed plus 3x squared y cubed. What's that?
$10x squared y cubed.
Yeah! The x squared y cubed, ladies and gentlemen, that makes them like terms does not change. The only thing we're doing is adding the coefficients together. This says I have 7 of these plus 3 more of these, so I end up with 10 of these. The these doesn't change. And it's like people say, well, you can't add apples and oranges. You're right. Why not? Because they're not the same thing. They're not like objects. These are not like terms. So we cannot add them together. The only time we can add them together is if they're like terms. Gabish? Sweet. Let's jump to the next page, ladies and gentlemen. I've given you an algebraic expression here. Please write down how many terms are there. How many terms are in this expression? Type it in, don't hit enter. Go! Enter. Yeah, that's it, ladies and gentlemen. There are 5. 1, 2, 3, 4, 5. There are 5 terms. There are 5 terms that are being added or subtracted from each other. Very good. Okay. So, now what I'd like you to do, ladies and gentlemen, is simplify the expression by combining the like terms. Ready? Go. Okay, ladies and gentlemen, this is what I got. I look at this and I'm like, okay, I got a 6x squared and a negative 3x squared. So if I combine them, I end up with 3x squared. Like terms. I also have 4xy and a plus 8xy, which gives me a 12xy. There are no like terms with the 4x, so I am just left with minus 4x. So there we go. We went from 5 terms to 3 terms by combining the like terms. Very nice. Are we all good? Okay. Next thing I got for you guys, I'm not going through all these properties. You guys have seen these properties before, yes? They've jammed them down your throat in the past? Okay, well, I'm not. Let's go to number 6, though, the distributive property. This is the one that I need you to understand. And I think you'll remember the name of it, but I'm more so interested in that you know how it works. Within the parentheses, we have an algebraic expression that consists of 2 terms. When you have a value out front, you need to multiply every term in the quantity by the value outside the quantity. So in this case, the x and the 3 both need to be multiplied by the 6. This is the distributive property. So I multiply the 6 times the x, and I multiply the 6 times the 3. 6 times x, 6 times 3, and of course it's added, so I leave the plus in there, and I get 6x plus 18. Every term in the quantity needs to be multiplied by the value that the quantity is being multiplied by. Let's try another one. You guys can write this one down. Let's write down 3 times the quantity, 2x minus 7. Go ahead, use the distributive property for me, please. Uh-oh, who did I lose? Ladies and gentlemen, 3 times 2x, 6x, minus 3 times 7, 21. 6x minus 21. Very good. Okay. La 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 la.